Hi guys, this is Raj, your moderator today. This is free webinar by JavaScript Meetup Bangalore group. This is part 2 of JavaScript beginner series. The audience could be new to programming language or new to JavaScript. Today's speaker is Abhinav Seelan. He is a full stack web engineer at hascode.com. He has been working with web technologies for almost 2 years now. His interests are end-to-end JavaScript stack on daily basis and enjoy learning about and sharing the lesser known aspects of the language on the web. The duration would be loosely around 1 hour. You can post your questions in YouTube chat window itself. Abhinav will answer either end of the session or in the middle of the in the middle based on nature of the question. Um, let, us, let us now start without wasting any more time. Over to Abhinav Sheelan.
Hi Raj, and hey everyone who's online right now. First things first, thanks a lot for taking some time off on a Sunday afternoon to kind of learn about the language. So hats off to you guys. And thanks a lot for the introduction as well. So I work at Hashnode as a full stack engineer, and Hashnode is a platform for developers to meet and have discussions about code and about programming life. So you guys should check it out. That being said, today's topics are around data types, arrays, objects, and functions in JavaScript. And as Raj mentioned, so the target audience can be anyone. So you could have some programming experience, but a lot of what I'm going to be teaching you today would be from the standpoint of someone new to programming itself. So if there's anything that I would have, if there's any part that I want to compare with other programming languages, I would mention it outright. So before we begin, just as a small refresher for those who attended the previous webinar as well, and for those who are joining this for the first time, I'll just do a quick recap of everything that was covered before, a small recap. So we spoke about what JavaScript was. So JavaScript is a language for the web. It was built initially to sort of provide a way to add interactivity to your bare bones HTML and CSS websites. But over the years, it's evolved as a language, and it's a pretty versatile language that you can use today. And the place where JavaScript runs is in the browser. Let's keep it to the browser for now. Over the years, like I said, things have changed, and we've pieced out the runtime to allow you to run JavaScript in other places, such as things like Node.js, which is beyond the scope of this talk, but let's just keep it to the browser for now. We also covered something called variables. So variables in JavaScript, just like any other programming language, is pretty similar to algebra. So the way you would write x is equal to 5 in normal algebra, and at any place, if you use x in any equation, you know that the value of this is going to be 15. And that's because this variable here holds the value 15. And similarly, in JavaScript and any programming language for that matter, you have something called variables. So in JavaScript, to create a variable, you use the let keyword, and you can provide any name for it. Let's use x as an example, and store any value in it. And you can use this variable across your program to reference this value. So we also learned about console.log, which is a function that allows you to print stuff to the console. So using x here, for example, and running this snippet would print 10 to the console. Also, for those who followed along from the previous webinar, I'm using a service called JSBin, that is jsbin.com, which kind of makes it easier to type out longer sections of code. We were using the developer tools in the first session, but I'll be using JSBin here. So you can follow along on jsbin.com, or you just make sure that you've selected the JavaScript and the console tabs on the top, so that you have a place where you can write only code and see the output accordingly. Also, I kind of forgot to mention that in the YouTube video description, you should find a link to a repository where I have a written transcript of everything that I'm going to be talking about today. So you can check that out right now. It's a written version of everything that is going to be covered today with examples as well as quizzes for you to test your own skills out. So I highly urge you to do that because a lot of things that I do here would just touch and go upon topics, but there's a more in-depth explanation in the repository. So that being said, so we had variables. We also had something called constants. So here, a variable x can have any value, but it also allows you to change its value at any given point in time. And that's the whole point about variables. It has variable values to it. But then JavaScript also allows you to specify constants using the const keyword, which basically binds the value that you've specified here to a variable that cannot be changed at any point in the program. So if we have let x is equal to 10 and x is equal to 20 here, and then we run this, you can see that 20 is printed to the console. But the moment I change this to a const and run the same snippet, you'll see that there's an error saying that you can't reassign a value to a constant variable. So we have constants in the language as well. And we also did operators. So, I mean, a program at the end of the day is you taking in values and performing some operations on it. And you can perform operations on it only when the language supports operators. So we had three types of operators. So we had the numeric operator or the numeric operators. We also had the comparison operators. And we also had the logical operators. So the numeric operators are pretty much the same as their algebra equivalents. So we had plus, minus, multiplication, division, and a new thing that's specific to programming languages, which is the modulus operator. So I'm just copying over a snippet that I had up for the repository. So here we have A is 10, B is 5 as two variables, and performing any numeric operation on them would spit out the evaluated result. So we have A plus B, which would print 15, A minus B, which is basically 10 minus 5, 5, 10 into 5, 50, and so forth. So you're running the snippet, you can see that it has the corresponding output to the console. But the modulus operator is a little different because it does the exact same thing as division. As in, it does A divided by B, but instead of returning the quotient, which is what you usually get from the division operator, it returns the remainder. So console.log A mod B would return 0 because 10 divided by 5 has a 0 reminder. If I change this to 13 and run the same thing, you can see that's 3. So the modulus operator returns the reminder of the actual operation. We also have the comparison operator, which compares an LHS and an RHS and spits out the value that the result of this comparison. So if you take this snippet, for example, we have 10 greater than 5, which would print true, 5 greater than 10, which is false, and we have the less than operator, greater than equal to, less than equal to, and the double equal to as well. So if we run this in the console, you can see that we have the corresponding true and false values that are being returned based on the comparison that goes out. We also had logical operators, which were the AND operator and the OR operator. So the AND operator is a double ampersand, and the OR operator is a double pipe. And what these operators do is they compare the LHS and RHS again, but return based on certain conditions. So the AND operator requires that your LHS and RHS both be true for it to be true. Any other combination, true and false, false and true, and false would return a false value. Similarly, we had the OR operator, which is the same thing. It takes the LHS and RHS, compares them, But in this case, it just needs either of the LHS or RHS to be true to actually have a true value. So some examples are these console logs here. So we have true, true, false, true, and we have all the permutations. And running this in the console would give you the corresponding output that you expect from the AND and OR operators. We also went through something called conditional flow. So what conditional flow allows you to do is provide a construct within your program to have two different executions happen based on a certain condition. So let's take this for example. So the first type of conditional operation or conditional flow is provided by the if-else block. So the way an if-else block looks is it has an if condition that checks for a certain condition. So in this case, we have a variable called animal. And if the animal is equal to a cat, which is the condition that we're looking for, then it would execute this block and print out that it's a cat. Else, it would print out the next block, which is, in this case, a dog. So when we run this, you can see that it prints it's a cat. The moment we change this to, let's say, a dog and run this, we have a different output, which says that it's a dog. And yeah, that emoticon is the dog emoticon. Yeah. We also learned of another conditional flow called the if-else block, which is for multiple cases. So in the previous case, we actually had just two checks, one to check for a specific case, and if it's not that specific case, it has a default value. But if we have more cases, like in this snippet, you use something called the if-else block, which checks for a specific condition, and if that's true, executes this block. Else checks for another specific condition and executes the next block, and similarly again for another specific condition. And finally, if all of these specific conditions are not true, it then goes to a default else case. But this isn't the most prettiest thing to look at when you have, let's say, 5 or 6 different cases. So a way to solve for this is using something called the switch statement, which looks something like this, where you have the exact same functionality as an if-else block, except uses a different syntax called the switch case block, where given a variable, it's sent into the switch block, and every case evaluates some expression against this variable. So in this case, it checks cat against animal and console logs meow. If animal were dog, it would trigger this case, or if it was fish, would trigger this case, and if it was neither of these, would trigger the default case. We also learned, and the final thing that was covered in the previous session was loops. So we have 3 types of loops. The first one is called the for loop. Or before that, maybe I can get to the while loop, which is an easier construct. So we have a way to repeat certain code execution over and over and over again until we actually have a case where it no longer needs to be repeated. So let's say we want to print the values 1 to 5. So we know that we're going to do the print execution 5 times and then stop. So we can start with a value that maybe is 1 to begin with, and while the value is less than 5, I want you to console.log the value and also increment the value so that you can see the next value in the series, which is 2 or 3 or 4 or 5. So running this while loop, running this while loop will show you that it prints 1, 2, 3, 4, and the moment value turns 5, it fails this check, which is 5 less than 5, and the moment it fails it, would immediately move on to the remaining part of the program. But as you can see here, a while loop does the job, but the entities that define the looping construct, the entities that are involved in how you decide when to loop and when not to loop, are all spaced out across the application. For example, here we have the value, which is the initial value stored somewhere else. We have the condition specified somewhere else, and finally the way the value changes over time, specified somewhere else. So a way to solve for this was the for loop, which is a more declarative way of doing the exact same thing. So you would have a for loop defined using the for keyword. Let the value start with 1. Let the looping stop when the value is. I mean, let the looping continue as long as the value is less than 5, and stop the moment it is equal to or greater than 5. And on each loop, I want you to add 1 to the value. And inside this thing, the code that's going to be executed multiple times is specified inside the block console.log value. So now when we go and run this, it gives the exact same output, except everything that relates to the actual looping is within a single section here. And the last thing that was covered was something called the do while loop, which I won't go into too much detail, but it's similar to the while loop. And all you have to keep in mind is it executes at least once. And I'll be moving across this topic in the essence of time. So yeah, coming to today's topics, the first one is data types. So in the previous session, we learned about variables and the fact that they can store values. I think there's some questions on the chat. Just give me a second. Okay. Yeah. So the few questions regarding the link. The link is in the video description below, and you guys can check it out at any time. And those watching the stream after the live stream as just a standalone video, I really urge you to go through that link as well. So yeah, data types. We have variables in the language, but unlike other languages and unlike other programming languages, variables in JavaScript are dynamically typed. So what that means is that this let keyword is all you need to do to specify a variable, and you don't need to give it any metadata about what type of value is being stored. So in this case, we're storing the value 10, and this is a number, right? But we can also go ahead and change the value to something called a string. It is what we define with single quotes. And this is a completely valid operation in JavaScript, in contrast to other statically typed languages like C, C++, and Java, where you have to specify what value this variable can store. In JavaScript, you're allowed to change the value type as much as you want. And while the variables themselves don't have any type associated with them, like number, string, and so forth, the value that's being stored in them has a type. And JavaScript houses 5 different data types, which are called primitive data types, because these are the data types that are the most atomic. So the data types that JavaScript supports are the number data type, 2 is string, 3 is Boolean, 4 is undefined, and 5 is object. And I'll just give you a quick overview of each of these. So the number data type is any value that is numeric. So let a equal to 10 means that the value being stored here is a number value. And we, or at least in the JavaScript language, there is really no difference between numbers as integers and numbers as floating point numbers. So what that means is that a equal to 10 and a equal to 5.56347 are all number values. This floating point type and this integer type are both of type number. And we also have something called the string type, which is anything that you specify within quotes. So we have the single quote operator, which is hello world in this case, specified in single quotes. But strings can also be defined in double quotes. And there's absolutely no difference between the two. So your strings can be single quoted or double quoted, and it's all treated the same. But it is better to kind of stick to one type of quotes throughout your program and not mix up the two. Something that's new in JavaScript though is called the backtick operator. So you have the key just above the tab. That's called a backtick, and that also creates strings in JavaScript now. And I have a quick snippet as to why these backticks were introduced, but anything with a single quote, double quote, or backticks is a valid string in JavaScript. So why do we have another additional type of quoting methodology in addition to double and single? It's because of something called template literals, which is new in the language. So let's take an example to kind of understand this. So if I have this person, I have a person with a first name Tony and a last name Stark. And at any given point in time, I want to create a string that contains these variables. I would have to use the concatenating operator that we learned in the previous webinar. So we have my name is plus the variable that has to go into the position plus a space plus again the variable that has to go in the next position. But using the backtick operator, you can create something called a template literal. So my name is, and using the dollar and the curly braces, you can directly insert the variable that you want at that position. So in this case, it'd be my name is space a variable replacer space another variable replacer, and running this gives you the exact same output. So just a small pro tip there. Now, after strings, we have Boolean. So Boolean is usually the value or the type of value that's returned from a comparison. So console.log, we had 10 greater than 5, right? So running this returns the value true. This true is a Boolean value. Okay, and Boolean values are one of two types. You have a true value, and you also have something called a false value. And yeah, it is usually the output of a comparison operator. Then we have something called the undefined type, which is a really funny type in JavaScript. So what undefined is a valid type that tells you that the value being stored in a variable has not yet been defined. So we've always been doing this. Let A is equal to something, right? So what if I remove that something and just initialize a variable like this? If I console.log A at this point, you'll notice that it prints on undefined to the console. This undefined is a primitive data type in the language, which is there solely for the purpose of signifying that a variable has been declared, but the value being stored in it has not yet been defined. Okay. And finally, we have another primitive data type called objects, which is its own beast of a topic. So I'll actually stop here in terms of data types and get back to objects when I cover it as its own standalone topic. Now, while types are good, sometimes you as a programmer would always have a need to know what type is there inside a variable. And JavaScript provides a handy little operator called the type of operator that you can use to find out the type of value being stored in a particular variable. So again, starting with our examples, we have let A is equal to 10. If I console.log A at this point, it's going to print out 10. But if I prepend it with the type of operator, it's going to tell me in the console what the type of value being stored in A is. So running that is going to print out number, because the value that we stored here is of type number. If I go and change this to a string and run it, you can see that it's printing the type string. So the type of operator is extremely handy to understand what value type is being stored in the variable at any given point in time. So that kind of covers data types in JavaScript. If anyone has any questions, you can leave it in the chat and I'll get to them right away. Okay. Doesn't look like any questions are there, so I'll kind of proceed from here. So something that comes along with dynamic typing is the fact that there would come times when you try to perform operations with two. Sorry. Hmm. Yeah, so it might come times when you perform an operation with an LHS and an RHS that don't actually belong to the same type. Okay, um, and this kind of leads to some situations that you might think that you need to handle, but it is handled for free by the JavaScript runtime, and this is called type conversion. So there are two ways type conversion can happen when you perform an operation on two different types, and it can either be an implicit type conversion, which is also called coercion in the language, and you also have something called explicit um type conversion, and this is called typecasting. So going over coercion first. So what coercion does is if you end up in a situation where you've performed an operation on an LHS and RHS that don't have the same data type, the JavaScript runtime makes a decision for you to decide which type either the LHS or the RHS has to be converted to so that this operation can be successful. So let's take an example. If we have this, where we have a equal to 10, where a is holding a value of type number, and we have b, which is holding a value of type string, and we try to console.log a plus b. This is a completely valid operation, and what JavaScript will do for you for free is actually concat two strings. So what that means is that it's gone ahead and changed a here from type number to type string, because the plus operator here is being assumed to be a concatenating operator in this case. So what actually has happened is that this 10 has been converted to a string by the runtime, and it pretty much gives the same value if you do it yourself, right? So this is something called coercion that happens by the runtime, and this happens across the board, not just with the plus operator. So we can have, let's say, the subtraction operator here. So here we have a as a number again, b as a string. When you do a plus b, the assumption that the runtime makes is that the plus operator here means concatenation. So this will actually print 2010 to the console by converting 20 from type number to type string. But the moment you do a minus, for example, here, it knows that a minus has to be a numeric operation, which means that both the LHS and RHS have to be converted to type number because it's a numeric operation. So B in this case is converted from 10 as the string value to 10 as a number value. So this will actually print 20 minus 10, which is 10 to the console. So just run that and see. You can see that it's a string, which you can actually see here from the quotes. And also the fact that A minus B sends out 10, which means that both of them are converted to type number. And this is coercion and implicit typecasting in the language. We also have the ability to do this explicitly. So sometimes we don't have to give it to the runtime to decide for us what is correct and what is wrong, and also what value what type the value has changed to. We can also have explicit explicit control over this conversion. So the explicit typecasting happens using these methods: the string method, the number method, and the Boolean method, which kind of are self-explanatory. So if you have, let's say, a number, and then if you use the string method on top of this number, what it's going to do is take whatever has been passed in as the variable and take its value and change it to the corresponding type specified in the method. So running this is going to print out the string 10. I mean, you can make out using the codes that have been provided in the console as well. So we can also change this a to a Boolean value and run this, and you can see that the Boolean equivalent of the value 10 in JavaScript is true. So we have complete explicit control over this using these methods. I can also show you that the type of operator will tell you the new type that has been converted to. So if I run this, you can see that the type of Boolean of A is of type Boolean because this value was sent through this method and converted to a Boolean value. So this sort of typecasting is good, especially in a dynamic language like JavaScript, but it kind of runs into some nasty little edge cases that again are handled by the runtime itself. So conversions from Boolean to string are pretty seamless. Values from string to Boolean again are seamless. Number to string is seamless. But when you convert from string to number, you have certain cases that actually will not make sense at all. And to kind of highlight this, let's take a string value, which is hello world in this case. And what we want to do is convert this string to a number. So if I do console.log number of str, it's going to convert it to number. But if you actually think about it, this is a string value hello world. The string value 10 can easily be converted to a number, but the string value hello world does not actually have a number equivalent. So in this case, this is an operation that really does not make sense. But the runtime handles this in a pretty effortless way. So if I actually end up doing something like this and run it, you would notice that the console spits out a value called NaN. And what NaN stands for is not a number. So a value that has, or if NaN is returned to you at any given point in time, all you need to know is that you perform an operation on an entity that cannot be converted to a number. And the runtime throws this at you, and there are ways that you can check for this whenever you actually write programs. So the runtime kind of handles these edge cases for you, and it's a pretty seamless experience from there. So this is type conversion in the language. So we know that implicit type conversion happens by the runtime. Explicit type conversion is something that is given to the developer to kind of decide how the conversion should happen. And when a conversion happens and the conversion does not make sense, which is mostly with string to number conversions, you would be returned a value called NaN, which stands for not a number. So before I proceed from here, are there any questions regarding data types and the type conversions that happen in JavaScript? If you guys do have any questions, leave it in the chat. Okay, so let's continue from here then. So data types, type conversions. And the reason why I call them primitive data types is because at the atomic level, these are the only types that cannot be divided further, if that makes sense. Because there are some, and I'm using air quotes here, there are some abstractions that are given to the developer that allow you to build or model your data in your program that semantically makes sense. And one of those many abstractions is something called an array. So we have arrays. So an array in JavaScript is an ordered list of values. Okay, and to kind of highlight why arrays are extremely important in the language or in any programming language for that matter, let's take a small example. So let's say we have to have 5 fruits in our application. And the easiest way that, from what we know, to do this is using 5 different variables. So we have fruit 1, fruit 2, fruit 3, 4, and 5, which hold apple, orange, banana, grapes, and mango. So this is pretty straightforward. This is absolutely correct. but it doesn't make sense from uh, a developer's point of view, because fruit 1 has no civic significance. Fruit 2 again doesn't have any significance. All I know is all of these are fruits, like plural fruits. So what if there is a way that all of these can be semantically referenced by a single value called, or single variable called fruits? And that's where arrays come in. The way you would solve this is using an array, which you can create in JavaScript using the square brackets. So if I declare a variable with square brackets, that basically means that this variable is going to hold an array. And the way you would add values to an array is by specifying it within the square brackets. So apple, orange, banana, grapes, and mango. And that's about it. You've created your first array. So this entire array here houses fruits, and I can semantically use this variable across my application to talk about this list of values that I have that all mean the same thing. But unlike before, where we could have just done console.log fruit2, console.log fruit3 to access orange and banana, we can't do the same thing with this array. There has to be, there is another way that you can access values stored inside an array, and that is using the square bracket notation. So if we want to print out orange to the console, you would console.log fruits of something. So what goes here between these two brackets is something called the index of the array. So remember how I said that arrays are an ordered list of values? It's called ordered because there's an actual order to which these values are stored inside the array. And the order actually goes numerically from the first position, second, third, fourth, and fifth. And it's just a programming paradigm, but it does not start with a numeric value 1, but rather starts with the value 0. So 0 corresponds to apple, 1 corresponds to orange, 2 corresponds to banana, and so on and so forth. So the starting index is 0, and it just increments by 1 across the array. So here, to access the value orange, in my fruits variable, I want to access the 0th, the first index. And just passing in the value 1 here is all you need to do to get that value out of that variable. So now, similarly, if you want to access the value mango, we know that 0, 1, 2, 3, 4. So fruits of 4 is going to return mango to the console. So that is all you need to know for creating arrays. So now that we have the basic understanding of arrays out of the way, arrays in JavaScript are a tad bit special. And that has to do with the fact that arrays in JavaScript, unlike other statically typed languages like C and C++, can hold any value inside their array. So what that means is that this is a perfectly valid array, where you have the first index or the 0th index with a string, second with a number, third with a boolean, the fourth with an undefined value. This is a completely accurate and a perfectly valid array in the language. And another handy thing that JavaScript gives us is, with this variable list that points to this array, we also get some metadata. So if I console.log list.length, it will tell me how long this array is. So it has 4 values in it. So the length of this array is 4. So 1, 2, 3, and 4. We also can add values to an array. So let's go with the previous fruits array itself. So if you want to add another value to the array, let's say we want to add tomato, okay, to the list of fruits. All you need to do is, again, use the square notation to reference a position where you want this value to go. So here we know 0, 1, 2, 3, 4. So the 5th, which is going to be the position after mango, is now going to hold the value tomato. So if I console.log fruits and run this, you can see that it now holds tomato in the last position, because that's what I've specified here in fruits of 5. We can also modify existing values in the same array. So similar to how we added a value here, we can also reference an existing value. So here fruits of 0 is apple, and if I want to change this to pineapple, I can go ahead and do that. And now if I run this, you can see that the first position has now been, or the 0th index has now been replaced with the value that is specified. So I have direct access to any index, and I can change the value of them accordingly. You can also, given that arrays in JavaScript can basically hold any value, you can also hold other arrays within arrays. So for example, I can do this, where I have, just a second, yeah, where I have an array called ARR, and in its 0th position, I'm going to store a completely new array. First position, again, a completely new array, and second position, a new array as well. And this is completely valid, and this is what leads to something called nested arrays. We have nested arrays. So now if you want to access values inside a nested array, what that means is I need to be able to access the value 6, for example. You need to use the square notation twice. So console.log ARR of 1 is the array that we want to reference. And inside 1, we know that the 0 first, second position is where 6 is. And console.log 1 of 2 is going to return 6 to the console. So you can nest this in as many ways as you want. You can have arrays that hold arrays, and those arrays internally having more arrays. It's up to you as a developer, but arrays can hold anything, and there is no restriction on the values that can go inside it. So yeah, anyone has any questions on arrays, please leave it in the chat, and I can get to them, because we'll be going into something called iteration right next. Okay, so we had loops from the previous webinar. We have arrays from this, and something that loops kind of prove extremely helpful with is called iteration. And iteration is technically in terms of arrays is a way for you to go through an ordered list of values sequentially. So let's say we have an array ARR again, which holds values 1, 2, 3, 4, and 5. And we want to print out each value separately. Okay. And we also want to print out the index at which this value is being stored at. So the way you would put loops and arrays together is, in this case, let's just take a for loop, for example. So let the index, for example, start from 0, because we know that arrays start from index 0. We know that the index should not cross the array's length. So arr.length is going to be our delimiting condition. So once the index crosses the array length, we want to stop iterating. And finally, how do we increment the index? We increment the index once every iteration, because we know that everything is in order numerically. So index is index plus 1. So inside this block, I can console.log. We can use the backtick operator here, for example, and replace, let's see, array of the index at which I'm at right now is at the index. What I'm going to tell the console is that the value which is referenced using array of index is at the given index. And now running this would show you that 1 is at index 0, 2 is at index 1, 3 is at index 2, 4, and 5 accordingly. And this is how you would put loops and arrays together. And this entire process is something called iteration, which is a pretty common programming construct. But there's something that needs to be noted with iteration is the fact that sometimes you don't want to iterate sequentially. You want to have ways in which you can quickly move forward, skip a number, or even stop the execution altogether. And that's where two keywords come into play. One is the continue keyword, and the other one is the break keyword. So taking the above example itself, let's say I want to print all the even numbers. So I just want to print the values 2 and 4, but I want to iterate from 1 to the end and see see if there are any even numbers there, and the expected output is 2 and 4. So in my loop, I can put in a simple conditional block checking if the value stored at that index is divisible by 2, which we can do using the modulus operator. So if the remainder after a division with that value is 0, then we know that is an even number, and I want to print that value out. So there we go, console.log, the array at that. But if it's not an even number, I want to just continue. That is, I just want to stop the execution of the current iteration and immediately jump onto the next one. So running this it pretty much does what we want. We prints just 2 and 4, and this continue keyword would immediately stop the execution of that iteration if it's not equal, if this condition does not hold true. We can also break out of an iteration. So for example, let's say I want to print the value 3 and only 3, and I'm using an iterate and I'm iterating through the array. So here, if the value stored in that index of the array is equal to 3, then I want to print out found 3 and also break out of the execution, because I don't want to continue executing because I found my 3 and I really don't need to continue on from there. So now when I run this, it says found 3, but what actually happens is that it breaks out of the loop immediately. And a way that you can see this happen is, let's say I put a console.log iterated, and I put this at the start of every iteration. Now when I run this, you'll see that it prints it's iterated only 3 times, because it went through 1, it went through 2, it went through 3, found 3, and stopped the execution right there. It did not continue to 4 and 5, and that was all done using the break keyword. So that's continue and break and iteration in a nutshell. Do people have any questions? Looks like people have answered those questions. So now the last thing that I want to cover in arrays is something that is pretty handy on a day-to-day basis, and that's called array methods. So when anytime you go and create an array, so 3, this variable here that is housing the array has access to some methods and make it easier for you to perform certain operations on this array. So for the purposes of this session, I'll keep it simple. So there are some methods called such as push and pop, shift and unshift. And what these allow you to do is insert and remove values from this array. So for example, taking the fruits and the tomato example, we needed to count where the ending of the array was before inserting the tomato. So similarly, you can do the same thing with the array methods, but you really don't have to manually count or find out what the length of the array is. It automatically gets added to the front or the back of the array accordingly. So to give you an example of how push works, so let's say we have let ARR is equal to 1, 2, 3 as an array, and we want to add the value 4 to this. All we have to do is array.push, and inside these brackets provide the value that we want to push into this array. So now when we console.log the array, you'll notice that it says 1, 2, 3 and the pushed value 4. We also have access to something called pop. So arr.pop will oops. So we have arr.pop, which will take a value and remove it from the back of the array, from behind the array. So in this case, we have 1, 2, 3. Calling array.pop will remove the 3 from the end of the array and give you back an array with 1 and 2 alone. So executing this, you can see that just shows 1 and 2 because 3 has been removed from the array from the end of the array. Shift and unshift kind of work the exact same way as push and pop, except for the fact that it does it with the front of the array. So let's say we have 1, 2, 3, and you want to push a 0 to the front of the array. You would use something called the unshift operator or the unshift method. So arr.unshift of 0 will insert the 0 to the start of the array. 0, 1, 2, 3. And if unshift is to push, shift is the same as pop. So shifting a value from, calling shift on an array will remove the value from the front of the array. And in this case would give us 2, 3 as the remaining array because it's removed 1 from the front. So these are some really handy array methods that make adding and removing values from the array easily. There are a lot more array methods, but I want to keep it simple for the purposes of this webinar. So this is arrays and everything that you need to know to get started with JavaScript in a nutshell. So does anyone have any questions? Or can I go ahead with the next part, which is functions? So functions in JavaScript are a means, or functions in any programming language for that matter, is a means to prevent code duplication. So a function in a programming sense lets you have a small snippet of execution that you would trigger whenever you need that piece of execution to execute. Let's take a small example. So let's say we have 5 variables A, B, C, D, and E. And we want to go and print each of these guys, but while printing, we want to add the value 2 to it. So the way you would go about doing this is by console.logging the variable and adding an extra 2 to it before printing it out. So running this gives us 12, 22, 32, 42, 52, and so on. So while this makes sense and is completely doable, a point to note here is the fact that the code that we've written here is pretty much similar across the board, with only the variable changing, but not the entire logic itself. And this is where a programming paradigm called functions come into play. So a function, before we actually go into the example, looks like this. So using the function keyword and some name to reference the function, we can execute some code inside this snippet. And this can be called across our application at any given point in time to execute whatever is within this block. So the way a function is broken up is the name of the function itself, the brackets, which hold something called parameters, which are empty here, but I'll explain what parameters are in a bit, and also the body of the function, which defines the actual code that's being executed every time you call it. So let's convert our example here to use a function. So right up on top, call function of, let's see, add and print. Okay. So what add and print is going to do is it's going to console.log a variable plus 2. And now we need to place the variable that we want to add 2 to here. But where do we get this variable from? And that's where parameters kind of come into play. So these brackets here can hold data that you want to send into your function. So here in add and print, we want the number itself. And when we console.log, we want to console.log the number that was provided into this function with the value 2 added to it. So let's convert this console log to use our function add and print. So we have let a equal to 10, add and print a. And what happens here is a is the same as num in the definition. And when we pass an a here, it goes in here and we do console.log a plus 2. And that would give us 12. So we can similarly do it for the rest of these guys and change them to the respective variables. And running this gives us the exact same output, except in this case, we've moved all of our duplicated code to a single point in our application. And that is sort of where the whole point of functions comes into play, is the fact that this is now our single source of truth for this logic. So if we want to add and print, we know that any modifications we are to make to this logic has to happen in all but one place. And for example, here we have console.log num plus 2, but here we are really just hard coding the value we're going to add to the number. Let's say we want to make this more programmatic. We can actually add a value to num and get this value through the function parameters. So here we have a is equal to 10. Let's say I want to go ahead and print 15, which is basically 10 plus 5. Or here I want to print 23, or I want to print 37, 44, and 60, right? We can now just change the logic in one location, take in a value and add the new value dynamically. But just by changing one location, we can reflect it across our program. And it is pretty seamless to just pass in a new parameter and have it all be taken care of by a single source of truth. So now running this, you can see that's 15, 23, 37, and all the expected output that we wanted. And let's see. Yep, so now this kind of covers function parameters. It also kind of proves the point that a function is good, especially when you're trying to duplicate code, as it's the single source of truth, and any updates can happen in a single place rather than having to make edits across the application just because the same code is copied over everywhere. Now, coming to functions themselves, functions have access to variables in a slightly different way. And I won't go into details because it's actually covered as a separate topic in the next webinar. But variables in functions behave the same way as they would in any other program, except, so let's say I have some function here and specify a value a equal to 10 inside it. This variable will not be available to any accesses outside the function. So if I do a console.log a here, this a cannot reference this a because this is something called a local variable to this function. Okay, so if I actually do this and try to run it, you'll see that a is not defined as the error being thrown, and that's because this console log does not have access to the a that's inside this function. And this has to do with something called scopes, which again is going to be covered in the next webinar. But for now, you can just think of them as local variables to a function. That being said, functions have access to something called outer variables. So function sumfunc lets you access this outer variable, which is outside the block of this function. So if I console.log a here, this is a completely valid operation because this a references something called an outer variable that this function has access to. So we have local variables that are within the function's block, which are not accessible outside, but you have outside variables called outer variables that are accessible inside a function, regardless of where they're used. We can also go and return values. So functions are helpful for a lot of ways, but sometimes you don't want to do any operation that leads to, let's say, some UI change inside the function. Let's say you just want to do some processing, like an operation or a couple of operations and some modifications, and you want to just return this back to whoever's calling this function, just as a way of spinning off the logic to another place and getting back the value from it. So let's say we have the same example as before. We have a function called add number, which takes some number and the number to add to that number. So prior to this, we had our console.log here, which was actually printing it out to the user. But let's say we don't want to do this. We want to just perform this operation and return it back to the point at which this add number function is being called. That can be done using the return keyword. So adding a return keyword inside a function will stop the execution of the function at that point and return what it's trying to return from the function. So let's say let answer is a variable that is just going to hold an answer. Let a is equal to 10. And answer is going to hold the value returned by the function add number, who's going to take in the value a and also going to take in a number to add to a. So this a would go in as 10 here. This 5 would go in as the number to add. It'll perform 10 plus 5 and return the value 10 to the variable answer. And now when we console.log the answer, you will notice that it prints 15. That's because add number returned 15 to answer, and answer was then logged to the console. So we have functions, single source of truth. They can return values. They can also take in parameters. But a thing that you might run into constantly whenever you have to learn about functions in JavaScript is a term called functions are first-class citizens of the language. It's something that's thrown around a lot, and I just hope to kind of explain that right now. So functions, surprisingly, in JavaScript are pretty much treated like variables, if you can think of it that way. So remember how arrays could hold any value in them? You can also have an array that holds functions inside them, because functions are treated just like variables. You can also have a function that takes in a parameter, but when you call some func, you can pass in a function as the parameter t itself. It's a little bit confusing, but you can actually pass functions as parameters to other functions just like you would a normal variable. And the last thing, which is a little bit more surprising, or was surprising to me, was the fact that you can assign functions to variables the same way you would do a value. So let a equal to 10, but you can also have a equal to a function. And this is completely valid. So let's say this is a function that console.logs k to the console. If we call the variable now, it prints it to the console. It actually executes this function. So you can pass a function around across the language just the same way you would a normal variable. And that sort of is why they use the term first-class citizens, because in most languages, variables are, but in JavaScript, functions act the same way. So to kind of highlight the function as a parameter construct, let's kind of go back one step and go through array methods again. So we had push, pop, shift, and unshift, right? But we also have another method called for each, which is a means to iterate through an array without using a loop, basically. So the for each method allows us to go step by step through each value in the array, one by one, without having to use a loop. And this is done using a function as a parameter sort of syntax. So let's take a small example. So let's say we have an array of letters. and we want to iterate through this, and console log, similar to before, console log the letter and the corresponding index that it's at. So we have an array method called for each that we can use. But what for each takes, or the way, or what it's defined with, is to take in a function as a parameter. And what the function does is it takes the index and value on each iteration. So to kind of put that on paper, so we have for each, which takes a function as a parameter, and what the parameters to that function are the value itself and the index at which the current iteration is at. So inside this function, if I console.log value is at index index, so what happens is for every single value inside this array, it's going to trigger this function and console log the value at that position and also the index. And all of this is provided as a parameter to the for each method. So when I run this, letters. So if I run this, you can see that A is at index 0, B is at index 1, and all of these console log statements are coming from a function that was passed in as a parameter to for each. So this is sort of an example to kind of highlight the functions as parameters paradigm that is slightly new in comparison to other statically typed languages like C and C++. So something that also is new with functions in JavaScript is something called the arrow notation. And I'm just going to briefly touch upon this because they do the exact same thing as normal functions, but the syntax is different, and they also have a few other differences which kind of would be confusing now, but there is a separate webinar after this where they cover this keyword, which is sort of what it's related to. So we had let some function is equal to a function, and this is going to do some logic here. So this was the previous syntax for defining a function. What the arrow function allows you to do is it allows you to remove the function keyword here. It's just some sort of syntactic change, but it allows you to remove the function keyword here and add the equal to and like a right facing arrow to give you an arrow. And this entire block is now what you would call an arrow function. So the arrow function does the exact same thing as a normal function. So if I come in here and write a console.log statement, this was inside the arrow function, and trigger some function. There you go. It console logs just like you would a normal function. And the reason why there's a syntactical change is because it makes life a lot easier for you if you want to write smaller lines of code. A good way to explain this is that every single time you want to create a function, you have to type the function keyword, pass in a parameter, and then have brackets and have your logic written inside this. With arrow functions, you can reduce the amount of syntax you use. So let's say I have only one parameter called value. So if I have only one parameter in an arrow function, the parentheses here are optional. So you can remove that and just have a variable is an arrow function. And additionally, if inside the function we're not actually doing anything but just returning a value, so let's say this is an adder function which takes a value and adds the value 5 to it. If the only line of code inside the function is a return statement, then this entire curly braces is pretty much unnecessary. So you can shorten the entire function syntax to a single line that if you have one parameter, you can have the parentheses as optional. And if you're just returning a value, the curly braces are also optional. Why was this done? It actually gets it grows on you at one point, and you start seeing the benefits of this over time as you use the programming language. I personally would suggest using functions all the time until you get a grasp of it. But I'm just kind of introducing you guys to arrow functions because this is a sort of syntax that you might see. And I mean, you should be able to understand what this statement means. So what this means here is it's a function that takes in a value as a parameter and returns value plus 5. So that's arrow functions and functions in general. Are there any questions that I can address? Okay, it looks like so it looks it looks like everyone's already been answering the questions. So I'll proceed on to the last thing for today, and we're doing pretty well on time as well. So the last thing for today is the primitive data type that I conveniently left out from the previous section, which is objects. So objects are extremely important for the language, uh, because at some point in your journey through JavaScript, you'll slowly start realizing that everything in the language is an object. I'm just putting this out there, but it's something to keep in mind right now. So an object in JavaScript is an encapsulation of other primitive data types, or not just primitive data types, just other data types in general. So what that means is, let's again take an example. Let's say I have a person, okay, and the person has a name. So the way I would define this variable is person name is equal to, let's say, Addy, and let's say this person also has an age. So his age is 31, and this person also has, let's say, works at. So the person works at Google. So over time, you start noticing that you're creating or spinning off variables that are all somewhat semantically related. So all of these three variables, the name, the age, and the works at, all belong to a specific person. So why do they have to be their own variables? And also it gets extremely hard to kind of keep track of, let's say we have one person here, and in the future we have 10 other people in our program. So how do we know which person is which variable is pointing to which person, and so on and so forth. So all of these can be semantically encapsulated with something called an object. So the way you would define an object is using the curly braces. So let obj equal to the curly braces is all you need to do to define an object. So this is the object that is being stored inside inside the variable obj. So let's convert the top three variables into a single object. So let person be the variable name for the object itself. And what this object is going to have is a list of properties. All properties are just key value pairs, where the key is some sort of name that you want to use to reference the value being stored at that property. So this person, from the top three variables, you can see that this person has a name property, an age property, and a works at property. So is inside these curly braces that start specifying our properties. So he has a name property. So what is his name? You use the colon to separate a key and a value. So the key name is going to have a value ID. And similarly, he also has an age. So the age is the key. The value is 31. And after each property, you need to add a comma to specify that there are more properties that are going to exist inside the object. So we have the name, age. We also have works at, which is Google, right? And that's it. So now we can semantically, and we have semantically encapsulated all of these properties within a single variable called person. And this entire block here is what you would call an object. So same question as I had for arrays. So now we have this encapsulation. How do we access the individual values here? So before we could have just done console.log person name to get the value addy, right? So now we have an encapsulation. So we need to find a different way to access the value. And that is done using the dot notation. So all you need is the dot. So here you would the name to the console. We reference the variable where the object is being stored first. So person, and then using a dot specify the specific property key that we're looking for inside the object. So console.log person dot name. And now printing this out to the console, you see addy being printed out because we've referenced the variable that's holding the object, and then using the dot notation specifying which property key we're looking for, and then fetching the value from that property key. So similarly, we can also do works at and run this, and you have Google. So you can, and also you can also see that here the values being stored are all different types. So I can also have is the Indian? I don't know. I'll just say false. So you can have Boolean values, numeric values. You can have string values. It can be any data type, and that also leads to the next part, which is the fact that it can also hold other abstractions such as functions and arrays. So works at could be an array that says Google, and I'm just going to make them work at Twitter. But you can have arrays being stored inside your object as well. You can also have functions being stored inside your object as well. Console.log k, and you can also have other objects stored inside your object as well. So he's a person. Let's say the name is no longer a single value. It's going to be an object in itself. So a name can be an object which has the first name Adi and the last name is Osmani, for example. And now we have a nested object inside the top level object. And that, again, an object is an encapsulation of any data type, including abstractions such as arrays and functionality like functions and other objects themselves. And the way, for example, if I want to access his first name here, I would use the dot notation again, except in this case, similar to arrays, you would have to double the number of dots you use. So again, reference the variable you're storing this at, the property that you're referencing, which is name, and then inside that property, which is an object in itself, which property you're referencing, which is first. And running this would execute and print out addy again to the console. So objects encapsulating data types, any data type. It can be primitives, it can also be abstractions. And you access values using the dot operator. You can also have nested objects. And another thing that I had forgotten is the fact that you can theoretically have multiple words as a property name. So here I use the camel case to specify works at. But if I want to specify this as works at, as two different words, you can do that, but you need to use the quotes for it. So works at can be used. But in this situation, you cannot use the dot notation anymore. You actually have to use the square notation. So if I have to print this person's works at history, you would console.log the person, and then using the square brackets, do works at the entire string. And then if I run this, I get the array. This is just a small tip that the properties don't necessarily have to be a single word. If the need may arise and you want to have multiple words, you need to use strings, quotes, to make it a single string, and then access it using the square notation. And yes, after this, if you let's say we have the same person. Let's go back to when life was a little bit easier. and say the name is just ID. We don't have that, and yeah. So now we've created our object, but we also need a way to modify the values further. Okay, and this you can do again using the dot notation. So let's say this person has a name, age, and he's not Indian, but let's give him another property. Okay, so let's say I want to see if this person has um, let's say he's spoken at a conference, which I'm sure he has. So you can again use the dot notation. Person dot has spoken at conferences is true. So what this allows you to do is add a completely new property to the person dynamically, and uh, this is reflected across the program as well. So console.log person, and you run this, you can see that he has the new property has spoken at conference stored inside the object itself. You can also modify existing values similar to how we did with arrays by referencing the exact property you're trying to modify. So let's say I want to give him his full name instead of just his first name here. I can change person.name to Adi Osmani. And now console.logging the person. You can see that it's reflected as well. So you can add new properties. Existing properties can be changed using the dot notation. But there may come a time when you want to remove certain properties that you've added to the object. And that is done using the delete keyword. So if in this example we have this person and we want to remove the fact that we have some sort of Indian metadata, so I can use the delete keyword to delete the property stored inside that object. So inside person's object, I want to delete the Indian keyword, Indian property, and I console.log person. Run this, and there you go. You have an object without the Indian false because that has been deleted from the object now. And this is like pretty frowned upon. Sometimes I shouldn't be saying this now, but just keep in mind that the less you use this keyword, the better. You always should construct your objects and construct your objects with some thought in mind, and not dynamically add and remove properties on the fly. Just a pointer. There's actually a specific reason why this shouldn't be done. It can be done. It's just that if it's not done, it's actually a little bit more performant and better in terms of execution times. So yeah, so that is arrays, functions, objects, all in a small nutshell. There's a lot more to talk about each of them, but from an introductory perspective, I think I've touched upon all the major things that you need to know to at least get started, and also know that JavaScript is a strongly is a dynamically typed language, in the sense the variables can hold any type, but the values being stored have their own type, and the runtime manages type conversion for you implicitly, but you also have the ability to do it explicitly if the need may come, or you actually have a need for it. That being said, I think I've actually come to the end of the session. If you guys have any questions, after this or right now, you can actually reach out to me on Twitter. My Twitter handle is Abhinav Seelan. It's on the GitHub repository. You can also find me on Hashnode. Like I said, it was a platform for developers to have discussions. So you can have a discussion with me if you want. And you can also go to JS Meetup Bangalore's Slack channel. We have a dedicated channel for this course, where you can ask all your questions, and all of us will get to you as soon as possible.
Thanks, Abhinav. This is Raj here. So actually, I have collected bunch of questions from the chat window. and I have posted to your Slack. So maybe you can. Most of the questions has been addressed by our community itself. Still, we like to know your opinion on that.
Yes, I have some time, so I'll actually go through this as well. Thanks, Raj.
Yeah.
So let's see. I'll go through the list from easiest to hardest because it's actually varying a range of difficulty. So Shruti Sadashiv had asked a question about using index plus plus. Yes, and what you actually mean here is in a for loop, where I had written this, right, where index is equal to 1, equal to 0, index is less than some array dot length, and index plus, I mean, equal to index plus 1. So what you could do here is something called the what is it called? It's the increment operator of sorts. So the statement here, index plus plus, I mean, index plus 1 can actually be shortened to index plus plus, which means that the value index is going to be incremented by 1. And the reason why this is important is because this plus plus operator defines how this increment should happen. So you can actually provide the thing before index, which means that it'll be incremented before it's actually used, or it'll be used and then incremented. And for all intents and purposes, index plus plus is synonymous with index is equal to index plus 1. It does the exact same thing. I just wanted to make it as explicit as possible, which is why I left it as index is equal to index plus 1. There's also another shorthand that you could probably point out, which is you can actually provide, if you are incrementing or making modifications to the same value, I mean the same variable, like here index is being reassigned with the same variable plus some value. There's a shorthand for this as well. You have index plus equal to 1, which is synonymous with index is equal to index plus 1. You can also do like 5, which would mean index plus 5, and so on. Okay. I hope that answered your question. For each value and index are keywords. So that means you can have only 2 parameters for each function. I think this question was answered on the chat. I had seen this. So this is a question from Pooja. So in the array for each, right? So we have let array is equal to 1, 2, 3, and we do array dot for each. So the function takes a couple of parameters, not just 2. It takes in the current value at that position. It also takes in the index, and also the third value is the array itself that is being modified. So let's say we are actually iterating over this array, and this function is going to trigger for each value inside this, right? So it'll trigger first for 1, then for 2, then for 3, and so on. But let's say we want to actually also have some way to access the array itself inside this inside this block. So here we want to check if I'm trying to think of a use case. So let's say we are trying to find out if there are duplicates in your array, like that. Okay. So now you can have a current value, current index, and also the array to see if the duplicate exists in the previous versions. It's just a use case that I'm thinking of off the top of my head. So that is the third value that goes in, and no, the value and index are just function parameters. They're not actually like reserved keywords or anything. So this I can name this C, I, and A for all intents and purposes, and it should work. These are just function parameters. They're not actually keywords. So how to add and remove values in between the array? So another question for Pooja was on how you can add and remove values from between an array. So you can actually use there is a method called so there are multiple ways you can do this. So I'll talk about removing first. So in removal, you all okay. If let's say this is our array again, 4 and 5, and I want to remove 3. The steps that you would follow is to first take out these two values and then these two values and then move them out to a separate array altogether. So what you want to do is let's see. So I think array dot slice or splice. I forgot which one it was. Slice or splice. So I think splice is an array method that you can use that takes in two values, which is the starting index and the index to which you want to, basically cut out the array. Okay, so you can start from the 0th index and find the position of 3. Okay, which here is 0, 1, 2. Okay, and also take array dot splice of 0, 1, 2, 3, and 4. And then use both of these to reconstruct your array. Okay, so that can be done as well. Then, let's see. Can you repeat the arrow functions? So I'll actually just go through it again. So we have the function keyword, right? So we have this as a function. So we have some code here. So we have the function keyword and then the block to kind of define that this is going to be a function. Okay, so what the arrow function allows us to do is have us have less code to write in a way. That is just one of his many use cases. The other one that I was talking about was something to do with the way this keyword is being used, but that's for a later date. So let's say we have some function in the same thing that I've written here above in terms of an arrow function is the removal of the function keyword, okay, and replacing it with the arrow, okay, and also this can further be shortened. So if let's say we have only one parameter here, I can remove the parentheses, and if the code inside my logic is just a return statement, I can even remove the curly braces and just provide the return statement itself. So this entire block here can actually be rewritten as a single line. That is value plus 5. And the way you would read this is it's a function that takes value as a parameter and adds 5 to and returns it. But the moment you have more than one parameter, so let's say we have value 2 as well, then you have to add the parentheses. It's not optional. It's only optional when you have only one parameter. And so we compare object properties on an array of objects using sort. I don't understand your question, Om Prakash. Maybe you can expand on it at some point.
Okay, so maybe I can try to explain that. So he wants to compare two arrays. Arrays are key value pairs. So if he has no two set of or no array of objects, he wants to sort it. So community members already answered it, like we can pass it a function where we can compare individual properties, and based on that, it can be sorted out.
Sure. Perfect. Then I think there's time for one more question, which I just saw on the list. Okay. So there's a question here about objects are meant to hold a list of values in an unordered fashion. So I think there's a small correction to be made there. Like objects in general, there's really no notion of ordering or unordering. An object at the end of the day is just a way for you to encapsulate data that is of different types, basically, under a single variable name. So in the example of a person, you had a bunch of properties. You just like name, age, and whatever. So all of that is being encapsulated under a single variable, and that's about it. The ordering notion only comes up with something like arrays and I really don't see. So the tail end of that question was how you would order them if we need, for example, before rendering the list on any page. So if you have to do something like that, so it's custom logic that you will have to write to kind of take in the object, maybe alphabetically pick out the properties that make sense for you, and then print them out accordingly. So what you can do is I'm just sort of jumping the gun here, but you have something called object.keys as is that's a method that will return all the remember how I said a property is a key value pair, right? So it'll return all the keys for you. So let's say I have a person, he has a name, he has a age, and what I want to do here is make these an order. Let's say I want to order them alphabetically. The actual flow that you would follow here is you will have another variable called, let's say, keys, which is object.keys of person. So what that does, it takes the object person and then returns an array that has all the keys that it has. So if I console.log keys here, for example, clear, run, you'll see that it gives you an array of all the keys that are in that object. What you could do after this is then sort this array alphabetically or in whatever order that you want. And then using the dot notation, access each of these properties individually and display it on a list on the site. I hope that answers your question. And I think the rest of, can you please tell me where exactly we use JS and how JS is different from Node.js? So this is a question from Yogesh. So his question is where exactly we could use JavaScript. So kind of to highlight to go back in time. So in the pre-2000s era is when JavaScript is purely there for interactivity. So let's say I have a website, I click on a button, and the button shows a pop-up to me or changes something on the page, removes an input field, or adds an input field. So this is the sort of interactivity that JavaScript was initially built for. But over the years, it's actually changed to a programming language that has use cases beyond what was imagined for it when it first started out. We have JavaScript that is being written to build full-fledged enterprise applications. We have JavaScript that's being built to run on IoT devices. We have JavaScript being built that we actually have JavaScript running to write web VR, that web virtual reality applications using React VR and so forth. So it has a huge number of use cases today, which is why it's a language that is probably in my opinion, one of the best languages to pick up at the moment. And how is it different from Node.js? So throughout this entire webinar, I've been dropping something called the runtime. So the runtime is, you can think of it as an application that takes in your JavaScript code and executes it for you. Okay, and this runtime for the longest time resided only within the browsers. So you have the Chrome browser; it has its own runtime. You had Mozilla, which had its own runtime. So any JavaScript that was on that page or on the console would be run by the browser itself. Node.js was a huge paradigm shift in the way that the JavaScript runtime is executed, where the runtime the browsers used, they basically pieced it out as a standalone application so that you can write JavaScript and execute it in the command line, for example, on IoT devices, on servers that run half our applications. So that one of these experiments was Node.js, and it is pretty much the go-to solution right now for you to run JavaScript outside the context of the browser. There are a lot of command line tools that we use today that actually run on JavaScript, and they are executed by Node.js, which is their runtime. I mean, which internally uses the browser's runtime. I hope I answered the question. So Raj, I think we can wrap up for today. It's been a pretty long session,
correct.
but I hope I got most of the content out.
Yes, you answered almost all the questions. Thanks for a wonderful session, Abhinav. Guys, you may refer the companion Git repo at https://github.com/abhinavseelan/js for newbies 2. You may post follow-up questions in JavaScript Meetup Bangalore Slack group. We have specific channel called JS Newbies for this series in Slack group. Once again, thanks a lot, guys, for joining. Let us meet again in next part of the series soon. Thanks a lot for joining again. Bye.
Thanks a lot.